Okay, so here's the thing that we need to know, and it's so easy, and it's kind of cool. Well, it's not really cool, but it's kind of easy. And we're going to write it. If two things are equal and the bases are the same, then the exponents equal each other. Okay, somehow or another, when we write stuff in math form, right, the fancy math form, it doesn't make any sense. Like right now, if I said, explain that, you'd be like, I don't even know what that means. But when I show it to you, you're going to be like, oh my God, that is so freakishly easy. I totally get that, right? And let me explain what the heck that means. It means this. If we have a number like 3 to the 4th power, and I'm saying it is equal to 3 to some random power, obviously, if it's 3 to the 4th power here, what does this guy have to be? What's his only choice? 4th power, right? Because if these guys are the same, then these guys have to be the same. And that's the whole thing. That's the whole thing, is that if the bases, these big numbers, are the same, then if they equal each other, their little numbers have to be the same, right? So our goal today is going to be to solve some of these problems, which are super easy, or even make the bases be the same so the exponents can be the same. So here's the property. If the bases are the same, then the exponents have to be equal. You guys cool? Okay, so here we go. There are some rules to doing this. We're going to start with the easiest one, is the end one, and we'll go today a little bit easy, then a little bit harder is number 2, and then hardest of all is tomorrow. Okay? So what we're going to do, the first thing that's going to happen tomorrow, you're just going to write this down. The first thing that we're going to do is clean up the problem. Today, they're going to be clean. They're not going to be messy. What I mean by that is they're going to have stuff all over the place. But today, nice and clean. So we're not going to worry about that. Make bases match. We're going to talk about that in a little bit. But mostly what we're going to do is this today. Ignore dumb bases and make exponents equal each other. This is mostly what we're doing today. We're mostly going to be doing this today. We're going to be ignoring the dumb bases and making the exponents equal each other. When we do these after a bit, right now you're like, what the holy hell is she talking about? As we do them, you're going to be like, oh wait, this is pretty easy. This is pretty easy. So here we go. I'm going to give you some examples. You're going to do them. You guys ready? Here we go. First example. Super, super easy. Are you ready? Example number 1. If the bases are the same, you get to ignore them. So to do this problem, watch what you do. Yay! Math is fun! Yeah, that's it. That's pretty much the basics of what we're doing. We're just going to go a little weirder, right? You ready to try a little bit harder? Okay, here we go. How about this? Honest to God, if you think it's really, is this really as hard as it gets? It is. It is. So here's what. Are the bases the same? Yes. Can we ignore them? Yes. Is it then just a baby math problem? So yes, right? Can you all do this? Every single person in this class I know can do this problem. Right? Move that 4 over. 2x equals 6. X equals 3. Easy? Yeah? Is that bad? Okay, try this one on your own, my little lammies. Here we go. How about 5? Ooh, new base. Try that one. It's scary algebra 1. Honest to God, if the base is the same, you just cancel the base. I just made this problem up in my head, so I'm having to do it. La la la. I'm going to get 3x over here, 15 over here. Did you guys get x equals 5? Does that seem right? X equals 5? Yeah? Yeah? Okay. So that's the board. That's as far as the math gets, right? That's the math thing. But these are kind of fun because we're going to get a little trickier now and say, well, what happens if the bases don't match? So we're going to learn some tricks to make them match. Are you ready? So here comes the first one we're going to try. Take a look at this guy. 5 to the x plus 3 equals 25. But here's the problem. Those bases, the big numbers, are not the same. One is 5 and one is 25. So I can't do the crossing out thing. But let me ask you this. Can I turn this guy into a number with an exponent that has the base of 5? What number would that be? 5 to the second power, right? So watch what I'm going to do. I'm going to be like, hey, dude, get out of here. I don't like you. I'm going to rewrite you like this. Look, now the bases are the same, right? So sometimes what you're going to have to do is kind of think to your head, how can I make those bases match? How can I make that happen? And then you're good to go. So the math is super, super easy tonight. But sometimes you're going to have to get kind of smart, kind of clever, right? So how about this one? Let's see if we try this one. 3 to the, I'm making them super easy because I want you to get the math of it. La, la, la. What is that? Have to think in your head, how do I make like 27 match up with a base 3? I almost always go to the smaller number if I can. And you know what that is? That's 3 times 3 times 3. Or 3 to the x plus 4 equals 3 to the third. Now it's super easy. I'm going to say x equals -1 again. Are we cool with that? Yeah? How about something like this? Ooh, this one's going to be scary. If you've been sleeping or playing on your phone, you want to watch this one. So Blaine's watching me on this one. Oh, I love this one. 5 to the x plus 2, I'm just making those easy, equals 1. This is a little tricky. Because if I take 1 and I raise it to anything, it's still 1. 1 to the first power is 1. 1 to the third power is 1. 1 to the eighth power is 1. So changing 1 is not going to help me. But I want you to think about this. Mrs. Weir taught you a property way back that can turn any number into the number 1. What is it? Do you remember? 0, right. If I take any number and I put it to the 0 power, it becomes 1. So what I'm going to do is I'm going to say, I don't like 1s anymore. What I'm going to do is change him to 5 to the 0 power. Does that make sense? Anytime we see a 1, we just change him to anything. We can make him a 15. I could do this problem with 15s here. And guess what? It wouldn't make any difference. Or 215. Still wouldn't matter, right? All I care about is that these go away, and I'm going to get x equals -2. Are we cool with that? So far, so good? I like these. We're going to do another weird one. Are you ready? I love this. Next one's my favorite. Oh, my God, I get so excited about this. 7 to the x plus 3 equals 1 over 7. We hate fractions. I hate fractions. You hate fractions. Everyone hates fractions. So guess what? We hate fractions. It's the F word, man. It is. There we go. Mr. Penovich hates fractions. He doesn't lie. So guess what I'm going to do? I'm going to put a little 1 there. Is everybody cool with that? What's the exponent that lets me move things if they're in the bottom, but I want to move them to somewhere else? What lets me move location? A negative does. A negative does. So this guy is happy here, but I'm not happy with him there. So I'm going to say to him, dude, I need you upstairs. And he's like, I don't want to go upstairs. Bad things are happening upstairs. It's like stuffing a baby. Go upstairs. And so he's like, fine, I'll go upstairs, but I'm not happy about it. And then guess what? The bases are the same. The bases are the same. So what's nice is no more fractions. Just move it upstairs. He's not happy. That's true. But I don't care. Those go away. And now I'm good to go. X plus 3 equals negative 1. X equals negative 4. Yeah? Okay. How about this one? Oh, I love this problem. I'm so excited about it. What about 1? Oh, let's say 1 over 49 equals X. Oh, sorry. I'm making this up in my head. 7 to the X minus 5. So the first thing I would do if it was me, I don't like 49. I need to rewrite 49 so it's 7 to something. And then I'm going to make it go upstairs, right? See if you can do that. See if you can figure out how to do this one. I love this problem. This is one of my favorite problems. And we'll do one more and I'm done. You're done. I'm done. Let's see. I am going to meet with some kids tomorrow during SS. So if you are one of those kids who feels like, Miss T, it's hard to find a time with you, could you maybe get me out of my SS? If you talk to me tomorrow at brunch or today at brunch, I will make a little list and I'll go up there and pull you out of your SS, unless you need to keep it. So guess what I did? I went like this. 1 over 7 squared equals 7. I kind of like these problems. They're kind of like a little game, right? And it's like, oh, dude, get upstairs. 7 to the negative 2 equals 7 to the x minus 5. And then these guys go away. Super easy. Super easy. Are we okay with that? I got one last one, and then I'm going to be quiet, and then you are on your own. How about this? How about I have 3 to the x minus 4 equals, 1. Oh, we're going to go hard. No, well, I won't go super hard. 9 to the x plus 1. Okay, this one's a little hard. This is our hardest one today. If you're like, these are easy. I'm like, yeah, I like these, right? So what? That's not flying. I just wrote it badly. So here's what. My 3 is my base. He's staying x minus 4. But watch what I'm going to do. I'm going to say 3 to the second power. But I got to remember, I already have stuff out there. And when we raise a power to a power, we distribute, we multiply, right? So that's the only thing that you got to remember. When I rewrite this guy as 3 squared, I'm going to do that action and then distribute him. So he goes away. It's a baby algebra problem. Is that cool? I like this because I feel like they're just a little game. It's a super fun game. That's it for today. I'm done talking. You can play on your phones. I would like to come around and help you and see a picture of the prom. If you got a picture of yourself, I would love to see that. You want to get that out. There are 14 of these problems. I think that numbers 11 and 12 are the hard ones. 13 and 14 are required. If you get a little, 11 and 12, stop it. Show like you're stalking. I'd like you to try 11 and 12, but don't quit and not do 13 and 14. Does that make sense? They're really fast. They go super, super fast. Everyone can try. This is on the quiz, and we do a little bit harder ones tomorrow. And then that's it. Not x squared. We'll multiply. 2x plus 4. When you raise it up, it's on the You're adorable.
This one
Oh, that.
looks a little better. A little bit.
Just make a just one.
Bachelor Tyler plays on
Pictures, I want to see pictures.
Yeah, I was saying speaking of things in the car.
What happened between Sebastian and Jeff?
What? Did something happen?
Basically, Sebastian was supposed to
Shocking.
eat each other's house. And then Gavin and nobody was there. Gavin, and then Gavin was
What did happen? You guys are all my
right upstairs.
Okay, I'm coming out and see pictures.
How many do we do?
You do a lot. But 11 or 12 might be a little dicey. You can actually move on. I guess I'll go. You were the fun. Huh? I see your. Yeah. Jason.
What photos was Jason showing?
Oh, look at that.
That's why I was like, everybody at my house.
Oh, I love it. That's big.
Like, he's still
Was it? Did you have to pull that much?
No, it was so tight.
Yeah.
I like on it today, so it was
Yeah, because otherwise it's. Oh, no. Really? Oh my God. Shocking.
Nah.
Joe. Oh, it's your girlfriend or just friend? Oh, that's her dress. And she's super pretty, so what's wrong with her? Ah, see what I'm doing there? I love her. That's gorgeous. And you look super cute. Because you're so tall, do you have to go somewhere unusual to get yours?
Yeah, I had to get it like,
Well, I mean, I had a friend of mine who played for the NFL, and he was like, I always have to go to the big guy shop. Yeah, because he's, and he wasn't bad, he was just big, like, you're really tall, right? You have to go to the tall guy.
really.
That's a thing.
the sleeves are always really like short.
Right, right. Tall guy shop. I saw a picture of you somewhere else, and it was gorgeous, I loved it. How was it? Was it, did you have to pull much on it, or did it
Cross, shape, size, a little bit.
Yeah, because it's a hard call to go, like, if you give it 10 inches, something like that more. Otherwise, it's like, oh. Oh, that's fabulous. Well, it looks great. Are you guys sophomores? Prom? No prom? Prom? Any prom here? You got it? Can I see a picture? Like he's like a... You two. You have one.
Was such a high edge.
So 12 and 24.
I'm coming back.
Remember the first play of the game when I got before it got pulled off the field?
For like 2 minutes?
Yeah.
I know these guys.
I was guarding him at the end.
It's like you.
Pushing on the stairs. He was getting
Sophomore or
pushed
sophomore?
on.
Yeah.
Prom? Senior. Did you go to prom?
No.
Oh, girlfriend or friend?
He was on back.
Okay, but that's a fabulous picture. Really pretty. You guys are great. I love it. Oh, wow. No, I gotta go back to that one. The back is so great on that. That could be like someone's foot. Christmas card. That's a fabulous picture. Did you go? Picture?
Oh. I'll show you.
Did you go?
I'm the old guy.
Okay, let me see how many of these are. Yes. I'm having Max though.
Max got it.
Yes, and yes, and yes, and yes, and yes, and yes. I feel like that's way too many. Where are you? Why am I talking to you? Are you upset?
Max card.
Oh my God! Look, I pushed. That's what does everyone push?
Yeah.
A little.
5 squared.
Little. Serious.
6, and then equals 5 to 0.
And it was the girlfriend or a date?
I didn't know that.
Oh.
Yes.
Oh my God! No, go back one. That is so huge. Oh my goodness. Guys. And I like how we all try to back out and they can't look at our picture. But it's your shit. We do that too. It's like, let's take our pen. No, my mom was like, she was in the back of the I know, it's like my kid's playing and it's like, oh look, it's the sprinkler head. Oh, that is so
Yeah. My head went straight. How good?
Oh, goodness.
I have two coopers, rotary scotch. See what that soda is?
And then he came out
Again, I like that.
I don't think that's what
hard covered into a shop.
Oh,
I
yeah.
was like, oh, dude, that's just you gotta watch it. I was like, just me and him.
Because we uploaded
Oh my God, that is literally maybe
We don't have one needle cut on. That's all.
yeah, you went. Yeah, it's just, you know what, it's brick, you can't open it. When they clean it up, and then maybe on Sunday they don't do it, and on Monday,
Crashed into the tree when he was drunk. We lost it.
oh, they,
Yeah.
I'm sure.
Why are you school? My mom said I was actually taking the kids outside with the shower.
Oh my God, you look so grown up. You look so adult. And you look like you could run. Okay, let's see. Okay, your mom is going to send that to like members of your family. If I just yeah, that was great. That's really good. Now, what did you go to the pump?
No, bro, it's been his house.
Okay,
Oh, what the hell? Tesla was his girl. No, he wasn't. Bro.
Dude, he apparently like just left Northgate one day and went to see for like half. Because I've got some buddies at CV that's like, you know, his name's Jack. Yeah, why? Came to CV one day at lunch and just hung out during lunch and stuff. He came there at lunch and then like the last two periods of the day he was just hanging out in class. The CV was they didn't care. plays consistently in the difficult times. If you can, then I don't know what it is. Do that line, not have it.
Yeah. I love every kid's costume.
No, I know, but I'm going to make it one minute.
Transfer good.
No, because he's on.
I'm not asking you to but I told him my prize was going to help the school.
I'm coming, I love it. I love that. Who can I help? Oh, yes. Yes. Yeah, so it's going to be 3 of these and 3 of what? And we practice over here. Who needs help? Who do I like this. It's kind of a game. Figure how can I, because the math is hard. It's just like, ooh, how do I move them around? Right? No one's doing it. Phew, pretty on me. Oh, that was it. You guys good? Everybody good? Big two. Now that you're awake. Still more. Mosin. No, I'm kidding. It's not. That would be funny. You know, this one, oh, she's not here. Oh, damn it.